welcome to this series on AWS Solution Architect Certification Sample Practice Questions. This is the part 2, and in this one we are going to focus on CloudFront. Okay, so this is our first question. So let's take a look at the question. So Americola launched a global website allowing users to participate in the Americola Life-Changing Experience Contest. The marketing team requested you to design a solution that is highly secure and can be accessed across 30 countries in the world, but allow business to block users from certain countries in case of any issues. The solution at a minimum should mitigate against DDoS attacks at layer 3 and 4. It should also protect against layer 7 attacks such as SQL injection, cross-site scripting, etc. The organization should seek support in case of DDoS attack and mitigate any additional cost incurred due to these attacks, as it had frequent incidents in the past where it occurred huge cost due to DDoS attacks. Which of the following options meets the security requirements? Okay, so what are the key things that the solution design needs? Let's take a look at that. First, it should be able to block users from certain countries in case of any issues. Okay. The second one, it should be able to mitigate the DDoS attacks at layer 3 and layer 4. So that's the second requirement. The third one is at layer 7, it should be able to mitigate attacks due to SQL injection, cross-site scripting. And then finally, if there is a DDoS attack, it should be able to seek support from AWS as well as any additional costs that are incurred due to these attacks should be reimbursed or waived off. So these are the 4 key requirements. Now let's take a look at what are the options we have. Okay, so the first option is CloudFront provides the ability to geo-block the users and should be good for this solution. It is true that CloudFront can help you mitigate some of these attacks because it's highly scalable. It also allows you to geo-block the users from certain countries. So it can possibly help in the first requirement that's there where you allow geo-block users. Okay, so that's a potential answer. Now let's look at the other options that we have. Use a combination of CloudFront, ELB, EC2 autoscale to prevent any denial of services to the end users. Yeah, you can do that. I mean, in a sense, CloudFront, ELB, EC2 and autoscale. If there is a large scale DDoS attack, you can increase your server capacity and your genuine users might not get denial of services. So that's a possible option, but it's not like a perfect option because then you're going to incur a lot of costs. So now let's look at what are the third option that we have. So AWS Shield standard mitigates the layer 3 and layer 4 DDoS attacks such as SYN floods and UDP reflection attacks. So that's true. AWS Shield is provided to all AWS customers free of cost, and it does protect against layer 3 and layer 4. So this definitely seems to be one of the options for the second requirement that we have. It should mitigate against DDoS attacks at layer 3 and layer 4. Okay, so we can be confident about this. Now the next one is use AWS Shield Advanced, which will provide you a 24/7 rapid response team to mitigate the DDoS attacks and mitigate the financial loss for DDoS attacks. So that's correct. So if you enable AWS Shield Advanced, it will provide you a 24/7 rapid response team, and also any charges that you incur or financial loss that you incur would be reimbursed. Okay, so this is definitely correct because that's what it is looking here to mitigate against DDoS, any financial implication occur due to the DDoS attacks. So this is definitely an answer, but what you need to also understand is that AWS Shield Advanced is actually a very expensive solution. Okay, now the last one is WAF allows the geo block functionality along with the ability to protect against cross-site scripting and geo block. So that is one of our requirements, that it should be able to protect against layer 7 attacks such as SQL injection, cross-site scripting, which other options do not provide. So this is definitely an one of the requirements that we have in the question. So this ticks the box as well. See, in the first option we had the potential option of also using a geo block. So this is being covered in the WAF itself. So possibly we don't need this option. So we have these three options that would fit into which would help meet all the requirements that are part of this requirement. Okay, so we had to choose three. So then 3, 4 and 5 are the right options for this question. Okay, let's go on to the second question. Okay, so a leading FMCG has a subsidiary across globe and allows the employees to share the marketing campaign material across countries. The content contains a lot of video files and other large download files. The content is hosted in a S3 bucket in the US East region and accessed across the globe. The IT team wants users to access the content through the CloudFront distribution to avoid latency issues. However, they realize that users access both via S3 bucket and CloudFront distribution. What are the options available to the solution architect to allow access to the content via CloudFront distribution without direct access to S3? So they have global users and they have a bucket in S3 bucket in the US East region and it's accessed across the globe. So they have enabled the cloud distribution that should avoid the latency issues. But what they are noticing is that users are directly accessing the S3 bucket and cloud without using the CloudFront distribution. So how do you allow the users to directly access the S3 bucket and access all the content through CloudFront distribution? Because if they directly access the S3 bucket, our objective of reducing the latency is not going to help. So what are the options we have? Let's take a look at the options. Okay. So the first one is use multi-pod upload functionality that can enable quick access to the content of S3 bucket in a secure and additionally block direct access to S3 bucket. Okay. So multi-pod upload does not help in this. Multi-pod upload is useful when you want to upload large file to S3 and avoid any latency issues, right? So this does not help in what it is trying to ask. So that's not the correct answer definitely. Use S3 transfer acceleration to access the files using CloudFront distribution without allowing the direct access to S3. Okay, so S3 transfer acceleration is again to upload when you have to upload large files or videos onto an S3 bucket, which is in a geographically different location. So it's all to avoid latency while doing the upload. So it does not help with what we are looking to seek here, which is direct access to S3. So this option is also not correct. Okay, now let's look at the third one. Use OAI, origin access identity, users to control access to S3 bucket. Using OAI allows to restrict the direct access to S3 and allows only CloudFront distribution to fetch the content from S3. Yeah, this is correct, right? You use OAI, which is like an IAM role, which allows only the CloudFront distribution to access the content directly from S3. No user can actually directly access the files in S3. So if we enable this, it should solve the challenge. So this definitely seems like a good option. Now let's look at the last one. Use a combination of custom header and ELB to block the direct access to S3. So if you see how the S3, which has static content, CloudFront distribution, and ELB work, which is for the dynamic content. So when you have the static content, it will go from CloudFront distribution to S3 and fetch the data. If it's a dynamic content, then it goes to ELB. Now, if you want, users can also access the CloudFront distribution, or they can access the ELB directly. So which is what you want to try and avoid. So in that case, use the custom headers. But here we are not talking about dynamic content. We are talking about static content, which is hosted in the S3 bucket. So while it is correct, but it doesn't meet the requirements of the question. So this is not incorrect in this case. Okay, let's move on to the next question. Okay, here is the right answer for this one. Okay, now let's look at this question. A leading sports brand launched a new global application allowing users to upload their video. So they are doing an upload, the video of their favorite sports moment across 30 countries in North America, Europe and Asia. So it's a global application using their brand. At the same time, watch the promotional videos of their new upcoming advertisements based on their favorite sports star. The channel becomes an instant hit, but the users are complaining about latency in the uploading large videos from US and EU region. The S3 origin server is in India and the application is using CloudFront distribution for static content. So what are the options available to solution architect to overcome the latency issue? So in this question, what it is saying is that the S3 origin server is in India. There are users across 30 countries who try and both upload and download the content using the CloudFront distribution. But users are facing latency issues specifically to upload the videos and some other static content. So now let's take a look at what are the options you have. The first one is enable the cross-region replication of S3 buckets to reduce the latency issue. Cross-region replication is good if you have one or two regions, so you can cross-replicate across S3 and that might reduce your latency issue. But this is across 30 countries, so you cannot have like S3 bucket across 10 regions or so and they're trying to cross-replicate. So this is definitely not a good solution here. Use the S3 transfer acceleration to upload the videos to S3 bucket to reduce latency issues. Additionally, use multi-part upload to speed up the process in case of large file. Yeah, this seems like a good option. S3 transfer acceleration is mainly used when you want to speed up your upload process. So what S3 transfer acceleration will do is it will hit the endpoint of the nearest point of presence of the CloudFront distribution, and once it hits that, then it will use the AWS dedicated network to allow you to upload that file to the S3 bucket wherever it is located. So it doesn't use the public internet, so it can drastically speed up the upload process. The second one is use the multi-part upload to speed up the process in case of large files. So multi-part upload can definitely help you speed up the process. I think AWS recommends if it's more than 5 MB, you should use multi-part upload to speed up the upload process. Okay, so this is definitely correct. Now let's look at the third option. Use origin access identity user controlled access to the S3 buckets using OI allows restrict direct access to S3 and allows only CloudFront distribution to upload the content to S3. Yeah, that's correct. What the statement that is being mentioned here is correct, but that's not what we are looking for. We are looking to reduce the latency in upload process. So this doesn't seem to be the correct option based on what is the requirement. So the last one is use a combination of custom headers added to CloudFront with ALB and S3 transfer accelerant to speed up the upload process. Yeah, so here it's correct. You can use S3 transfer acceleration, but custom header is again restricting access to the ALB for dynamic content. So this is not correct. The correct option for this solution would be option 2. Okay, now let's look at the fourth question. Okay, a leading phone manufacturer has developed a global application with CloudFront distribution and uses multiple origins for static content and dynamic content. It protects direct access to S3 using OAI, but needs users to access dynamic content via CloudFront rather than directly accessing through the ELB. It additionally wants to enable a CloudFront origin failover strategy. What are the two options available for the solution author to modify the solution to align with the requirements? So basically there are two requirements. One, it should not allow direct access to the ELB for dynamic content, rather it should go through the CloudFront distribution. And the second one is if the primary origin fails, it should allow a failover strategy for CloudFront to access the secondary origin server for its content. So let's look at the option. The first one is use ELB to allow traffic only through S3 bucket, which is protected through the OAI IAM role. Yeah, this is not correct because it allows OAI IAM role is only for protecting the S3 bucket direct access. So OAI only allows the CloudFront to access S3 bucket, but not the general user. So what we want is for ELB, not for static S3 content. So this is not correct. Use the Route 53 DNS hosted zone to route traffic to ELB and use Route 53 health checks for determining the origin failure and use the secondary cloud origin. Okay, so that's one of the possibilities where you can look at the Route 53 DNS hosted zone, which can monitor the ELB, and if there is a failure, then it can route the traffic to maybe an ELB another region. But this is not an optimal solution. So let's take a look at other solution that we have. The third solution we have allow CloudFront to add custom headers to all the requests, which can then be validated by ELB to allow only traffic through the CloudFront. Yes, this is definitely a possibility where when the request comes, the CloudFront distribution adds a custom header, and when the request goes to ELB, it validates that customer header, and if it matches, then it allows the request to be processed. So this is definitely one of the options. The second one then was on the how do you enable the origin failover strategy. So in the CloudFront distribution, you can set up the option of having the secondary origin server. So this is a capability that CloudFront distribution provides. You can select the secondary origin server, and if it detects the first one has failed, then it will switch over to the secondary origin server. So then this is the second correct option to meet all the requirements in this question. Okay, so 3 and 4. Yeah, I think that's pretty much it on this section. I'll see you in the next session. Thank you.